before we get into the actual program and have a look at the design and calculation of slabs in our CYPECAD solution, what I like to do is just show you guys the workflow. So this diagram actually demonstrates it quite well. So for instance, let's have a look. We would usually start a project with a physical 3D model. Now, this physical 3D model can either be created in our own program called IFC Builder, and that's in that native IFC format that we like to use at CYPE, or it could be, or you can actually bring in your models from other modelers, so such as Allplan, Revit, ArchiCAD, all our different architectural models. We can actually bring those in to our workflow by using our plugins and also some specialized applications that we've developed to copy the sort of building information and bring that into our IFC format. So once that's done and we have our actual architectural model, architectural model being the sort of fundamental components of a building, your walls, your slabs, etc., just the sort of positioning and rough sort of description of those things, of those architectural elements, and things such as that as well. So once that's done, just quickly, what's his? Bupendekur says there's no audio voice. I'm not too sure. Maybe it's on your side, sir. Just check it out on your side, because I can see that everyone else is fine with the audio. So where was I? So once we have that architectural model, we can bring it into our shared information, and so that shared information basically is the it is that BIM service center that we're going to have a look at in just a moment. So what we basically have is a one-stop shop where we can save different models from different specialized applications into one single location. So you can see here the specialized tools. These are all things that can be updated onto the architectural model and saved in one location. So for instance, our structural model. So today we're going to be having a look at our CYPECAD application, which is a part of our structural model. But the list goes on. MEP, lighting, energy, acoustics, water consumption, energy. We basically have a vast range of applications. For basically trying to demonstrate here is the overall workflow, the workflow that we like to employ. We have the physical 3D model here. So that physical 3D model can come in from any other application that that's used, ArchiCAD, etc., Revit. That becomes a part of that shared information, and then we can then use our own local tools, our own native tools, such as CYPECAD, which is the one we're going to go through in just a few moments, and then all our other programs, and basically create layer upon layer of a BIM project, right? And so the benefits, what are the benefits? These technical documents, this is just one benefit among the others, but these technical documents can all be achieved and accessed through the BIM Service Center. So it's a one-stop shop for any professional, any sort of stakeholder to come into our project, come into the project that they're a part of, and access those documents. So specifications, cost estimates, etc., all in one particular location. Before this workflow, it was difficult to obtain different documents from different people that were spread out, etc. Now, that's a little bit about the workflow. Let's have a look and go into the BIM Service Center. So this is it, bimserver.center. For all of you guys that don't have an account or have no idea what this is, basically, again, this is the sort of hub that we like to use for our projects. I'm going to log in on the right-hand side here. If you haven't made an account, you can do this and register. So click register, name, email, and log in. No worries. So I'm going to log in now. And I'll be greeted with my dashboard. So this is basically where all your projects, contacts, etc. are all located in. Let's go into projects, because what I want to actually do is demonstrate the workflow before we can get into a program. Because, for instance, This is a powerful tool that I like to mention. Let's open up CYPECAD now. So basically with that BIM Service Center, that's the one-stop shop where we can download applications, we can collaborate with our project team members, etc., and have a look at the different options for sharing our project, different ways to obtain certain things, different ways to present as well. This is another great feature, is that you're a consultant, etc. We can actually demonstrate that later, but actually the sort of power that a one-stop shop has in regards to presenting projects is quite great as well. Okay, so this is CYPECAD. This is the homepage. We have the option to create a new project. We have the option to look into our files and create them as well, and some examples that we can actually have a look at, and they're actually inbuilt, these examples. But what I'm going to do, because we don't have a lot of time and I'm trying to get through as much as I can, let's have a look at creating a new project. So upon creating a new project, let's create a random name. I get asked if I want to import a BIM model. So what this basically means is if I already have a project in my cloud, in the BIM Service Center, do I want to use that as a model to make my structural model? So for instance, if I have an architectural model, do I want to bring that in and then model my structural model on the architectural model? In most cases, you would select yes, but here I'm going to select no. And then we get greeted with the input options. So we can create an empty project. We can import a job from Cype 3D. Cype 3D, of course, is our metallic structures program. And we can actually have a look at, I don't know if you guys were at the webinar, but we actually did a webinar on the interoperability between our metallic structures program and our composite structures CYPECAD program. But I'm pretty sure there is going to be one in a few weeks. You might have to have a look at the schedule if you guys are interested in that. And of course, we can create a automatic introduction from our drawing files as well. So if we have those DXF and DWG files, we can import them into our program and then model, and then automatically model our beams, our floors, our slabs, walls, etc. on the drawing files. And it's quite nifty, this sort of tool. And of course, we can introduce a IFC file as well. In this webinar, I'm going to be creating an empty project because we don't have time to go into the sort of automatic introductions and the importing jobs. So let's create a new project. And then I get greeted with the general data tab. So what this basically means is, so this is the place where we can define our codes, rules, regulations, etc. that we want our analysis and our structural model to follow. So for instance, you can see all the different codes that have been incorporated in our programs. So from all the different materials and elements, we have the relevant codes. So you can see here all the different types of codes that you can select. For concrete, rolled timber, etc., etc. I'm going to keep with the Eurocode. I'm not going to change much here. You can, of course, introduce wind loading, seismic loading, and also fire resistance checks as well. Now, of course, we can select the type of selected element here. So you can see I'm not going to change anything here. I'm just going to move on. You can see, of course, we can create additional load cases and limit states as well here as well. And also, of course, for our section designs and effective length factors that can be amended in this section here. But that's fine. Even if you don't, even if you want to change something later, you can. And by doing that, you can just go to general data in the project tab, and you find yourself back here again. So you can make those changes. Okay, perfect. So this is our this is our home. This is our sort of home page. This is the column definitions tab. You can see on the bottom left-hand side. We would generally follow the tabs to the right. So we'd start off with our column and floor definitions, and then our beam definition, results, contour maps, deformed shapes, and then health and safety at the end. Now, let's have a look. What I want to do is actually create a simple structure and have a look at the design of a waffle slab. In this example, we're going to go through a waffle slab, how to analyze it, and also the different options that we have for our slab design. So for instance, I can't actually go through each particular slab and how to design it, but of course I'm going to select a waffle slab, design that for you guys, and I'm going to show you guys how to do all the other sort of different slabs that we can come across in the field and for our projects. Now, of course, let's get started. What I want to do, and then finally we're going to do the drawings, and I'm going to show you guys how to generate those as well. So initially, let's create. Let's amend our floors, for instance. So we can, of course, change the initial and final floor groups of that column. So, for instance, that would be for buildings that have larger than one floor. We can actually choose the final and initial groups. So let's accept this. Let's create my columns. So just by selecting the coordinate introduction, I can introduce one column. Let's go again 0, 6. Let's go 6. Oh, 6 again. Let's go 6 again. So I'm going to create 12 columns here. Sorry, 9, 6. And so here you can see I've introduced 9 columns here. And so now basically what I've done is introduce the columns. I can of course look at all the different options that I have before introducing my columns on the left-hand side here. So you can see all the different options that I mentioned before: horizontal loads, effective length factors, etc. I can actually edit those using this drop-down tab as well. Now, what we'll do now is we're going to move to the beam definitions tab, and we can actually have a look at inserting our foundation elements. So let's move down here. You can see here I can select my foundation or first floor. We can come to the foundation here. Of course, my columns are all here. I can go to foundations, foundation elements, new foundation element. I'm going to select this foundation reinforced concrete footing. Of course, we have different options. You can, of course, look at all the different options here and select accept and introduce my footings onto my columns, to the bottom of my columns. So now we've introduced our footings, of course. Let's move up. So now I am at the first floor. You can see if I come over here to my floor selection, the green line tells me that which floor I'm actually amending at that present time. Let's create some beams now. We can come over here to beams, define beam, and here is our family of different beams that we're able to select from. So as you can see, this is split into family initially, and then the type within that family. So here you can see this is the flat beams, drop-down beams, ladders beams, composite beams. Then we have non-structural limit beams as well for those for stair sections, etc. Timber beams and also steel beams that we can select. So you can see all the different types of beams along with their families. All the different types of families along with their types is what I was trying to say. So I'm going to keep it simple, a flat beam, and we're going to select a flat rectangular beam. Leave the width as 35 centimeters. I'm going to accept now. We can come over here and select a continuous beam, not a simple beam. And now I can go along and insert my beams. So simply by left clicking on each corner, and then once I'm done, right clicking and selecting finish introduction. Then we can move on to our other beams. Right click, finish introduction, left click, right click, finish introduction. So here you can see that I've defined my beams, and you can see the program automatically tells me that with the blue question marks that a slab is needed at this particular section. Now, what we would do now is move on to introducing our slabs. So this is the part everyone's been waiting for. But basically what we would do now in our beam definition section, come over here to slabs. We would come over here to our panel manager as well. So this is basically where we can manage all the different types of slabs and panels that are within our project, and also have a look at all the different types of specifications that we can attribute to those slabs. So this is all before analysis is done, of course. So we come over here to define panel, and you can see here all the different types of slabs that we have an option to select. So let's start from joint floor slabs. So here you can see all the different types of joist floor slabs that we can introduce. So reinforced slabs, pre-stressed slabs, steel, lattice sort of open web structures, and timber floor slabs as well. And also in situ slabs as well. So what we would expect to do if we wanted to do this, we would actually create our own particular slab, for instance. We can come over here, and you can see here that I would be given the option to create my own custom slab by, of course, attributing the geometry, attributing the design data as well, so concrete volume, types of form, deflection codes, etc., etc. You can see at the bottom here. And of course, upon all the different changes that are made, we have a diagram to aid the user in knowing exactly what they're amending in regards to the overall view of the slab. Now, of course, we have different types as well. So we can look at amending a beam penetration, general joist types, so single, double, triple. Of course, what I wanted to mention, and this is quite an important part that I like to stress, is that these slabs and the sort of amendments that you do within CYPECAD can all be saved and exported to your local drive. It can be shared with your stakeholders, and then at a later date, when you want to bring in your amendments, your design, you can do it easily just by importing from your library that you've exported before. So what we can actually do is basically save a lot of time in sort of amending the slabs, etc., etc. But if we already have these sort of slabs that we like to use, of course, in our library, we can bring them in quite easily. Now, of course, I don't have any slabs saved. So if I wanted to do, I'd have to create a new one. And then, of course, lastly, we can change the joist layout direction. Moving on, we have our hollow core plates. You can see here that I have some hollow core plates already saved into my computer. Now, of course, you can do those if you want, but of course, you can edit and edit your library and bring in your hollow core slabs if you wanted to as well. Moving on, composite sections as well. So quite important here. We have the option between a form deck and a composite deck. So you can see here all the different the different types of forms that have been inserted and imported from the specific code that I've selected. You can see here. I can select the dimensioning, and of course I can copy, edit selected composite slabs. So here you can see sort of similar type layout where we have the drawing of the slab with the side view, and then I can of course make those types of amendments to my slab here as well. Of course, by looking at thickness, surface weight, moment of inertia. So this is of course the sort of freedom that's afforded to the user when they're looking at amending their slab, amending specific parameters and details within the slab, going to analyze, seeing how the slab behaves, coming back, changing your preferences, and then this sort of really robust way of working is quite powerful. Now, of course, same sort of options, so parallel to beam, perpendicular to beam, and also for the slab to pass through 2 points in which you would have to select. Now, I'm going to skip waffle slab because that's the one we're going to use. I'm going to go to flat slab, of course, just your regular flat slab you can create. Of course, the only thing you would have to specify is the depth of that slab and also the layout direction. Map foundations as well. So this is for foundation slabs. We're not going to use any foundation slabs in this project. Now, of course, depth, seismic and accidental situations, persistent situations that we can create. You can see here that the program, whenever you see a blue arrow, I was about to say green, a blue arrow, behind that blue arrow is the library. So again, persistent situations for our foundation materials. You can see here all the different soil types and all the sort of characteristic indices for that particular soil type. I think that makes sense. Yeah. So you can see all the different types of soil and those indices that I'm able to select. I can of course define my subgrade modulus and also the layout direction as well. And then also looking at some awaiting definitions. So you can actually keep it so the slab is not defined. So looking at there's a sort of way to come back to the definition of a slab later. Back to slabs, panel manager. As I said, I'm going to create a waffle slab. So coming over here to waffle slab, you can see here that I also have some saved waffle slabs that are in my library. What I'm going to do is just cancel this. So I can come over here to waffle slab, create my own new waffle slab here. Of course, I have 2 different types of the form, either lost or removable types of form. I'm going to keep it as lost. Let's select new. This slab will be new waffle slab webinar sample. Now, upon selecting this, again, we're greeted with the same sort of setup. So again, I have my diagram of the slab here, and then also the types of amendments I can make to that particular slab. So for this waffle slab, let's create it. So what was it? Let's say, what was it? I can always change it later, 35 by 40 by 45 or 40, doesn't matter. So I can amend the material again. So concrete, lightweight concrete, ceramic, and polystyrene. Now I'm going to select polystyrene. I have the number of elements here. So 1, 2, all the way to 6 that I'm able to amend. I'm going to select 1 element here. The geometric data as well. So I can keep it the same in the X and Y direction or different in the Y direction. Now, of course, if I do that, I just have, I can change those X and Y direction parameters. Here, let's go for a total depth of 35 centimeters will do. Rib spacing will be 55 and width will be 10 centimeters. Now, of course, I can introduce my own concrete volume if I wanted to, and also my own self-weight of the slab if I wanted to. I can just do that. You can see here that the shading disappears, but if I wanted to, I can select it and insert my own self-weight if I wanted to. So then again, this would be up to the user to have a look at, to sort of assess whether the concrete, well, of course, if you were dealing with a larger slab, you would want to define your concrete volume and self-weight as well. So this is basically how we would insert our, create our own waffle slab. And so it's quite easy, this sort of intuitive way of looking at the different slabs. You can see here, we went through all the different types that we can create in CYPECAD. Now I've chosen a polystyrene slab, a polystyrene waffle slab that I can now accept the changes for. You can see here that the type is has been saved as new waffle slab webinar example. I get a diagram to represent the slab, of course, the description, and also again the rib layout direction as well. So I can do that here as well. But again, I can select parallel to a beam and select the beam that I want it to be parallel to. Now, if I wanted to again export this particular selection, I'd come over here, export to library. And so you can see here, file, blah, 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 already exists. Would you like to continue? You would select yes. I'm going to select no. And then you would come over here, import from library, and you can see all the different waffle slabs that are present in my library. This one that I'm selecting, again, the dimensioning was right, 5510, yes, polystyrene. Yes, I'll copy it to the library, accept. So I want to, upon selecting it, I'm selecting the beam that the slab will be parallel to. As you can see, I've just selected it and moved my cursor to the beam that I want it to be parallel to, and left-clicked again. We can of course copy panels. So coming over here to copy panels in the panel manager, selecting with the left click, I can copy the I can select the type of I can select all the different types of characteristics that I want to copy from that particular slab. So you can hear the plane is quite important. Types of form, insertion point, direction, and base reinforcement that I can actually copy or not copy if I want to. So here again, and selecting that and right clicking it. So now you can see my slab has been defined. Now drop panels as well. We want to introduce some or generate some drop panels. You can see that we can actually do that quite easily. So coming up here to slabs, drop panels just over here. We can generate drop panels just by selecting the generate drop panels. Of course, we have the option to configure them as well, and also to introduce them from our library if we have some. So generate, and here you can see all the different types of editing options that we have for my drop panels. But what I can do is just exit now, and you can see that those drop panels have been generated on my corners. Now, before we analyze this particular slab, what I wanted to do was delete some negative moment things. So we can come over here to project, general options. Now this is just what I like to do with the negative torsional moment redistribution. Make that 0, and now exit. So this is basically what our definition looks like. This is a very simple example, but this is the sort of workflow that we'd have to adopt in any project, in any sort of slab definition. Now, where are we up to now? We would want to, of course, we can actually have a look at our 3D view. Let's have a look at that. So just by coming over here, we can view my structure, my foundation elements, my columns, and also my slab with my beams as well. Now, what we can also do as well is introduce an opening within the slab. And I know someone's just asked a question, whether I can have a look. Now, to introduce an opening, I would come over here to slab, introduce opening, of course. And here you can see that I'm given the option to introduce rectangular openings parallel to beam, introduce rectangular openings with 0 angle, introduce rectangular openings matching with panel angle, and also introduce rectangular openings with any angle. So I'm going to select parallel to beam. Let's select this beam, yes. Here you can see I can select this beam, select the start section of that opening. And the final section. And here you can see by this blue cross, you can see that this opening has been achieved. So there is no slab there, and this is what the jagged jagged lines mean. I can come over here to the 3D view and consult that change, and here you can see the opening has been made. Now, of course, I selected it to be parallel to a beam, but you can do it anywhere else you like. Basically, you could do it so that it's open in the middle if you wanted to. That would mean introducing your own angle, of course. But then again, you can do it any which other way you like. So let's have a look. After this, we would, of course, go to analyze. So let's have a look. Let's just hope that everything's fine. We can have a look at our beam definitions. 35, and this is 35 too. Okay, perfect. Now let's go to analyze and analyze the project, including the foundations. So just give the program just a moment. It shouldn't take too long, as it's quite a simple structure. We will have a look at some different options after when we're looking at defining it. So here we have the project, so the analysis report. So basically all the different errors that have happened with my calculation. You can see here, section of the shear or punching stress reinforcement, fire resistance checks. So that's normal because I didn't introduce any fire resistance, and etc. They failed the shear punching, so we'd have to have a look at the foundation sections. So basically here you can see my beams, the ones in red with critical errors and the ones in yellows with not so critical errors, but still worth looking at. We can come over here as well after that to look at our results. And here you can see my slab with all its reinforcement that's been amended here as well. So here you can see I can zoom in and have a look at all the different reinforcement options here and my grid layer. Now, in results, we of course have different options to look at the results. We can look at our envelopes, beams, walls, etc. So this is where the bulk of the amendments will be made. You can see here waffle and flat slabs. I can of course basically look at modifying my reinforcement here. I can have a look at amending the reinforcement views. So here you can see these are the options that I have when looking at the reinforcement, not only in the program but also in the drawings as well. So here you can see I have some options, such as grouping the waffle slab reinforcements, different lengths, etc. That I'm able to select whether I want them viewed in the drawings and the slabs, or either and or the slabs. So that would be basically how we would define the reinforcement views. Now I'm not gonna play around with too much here. I can of course modify the reinforcement. So not only do I so here we would have a look at the modification of these of the reinforcement. So I can modify the diameter, the spacing, by of course selecting the different types of diameter. I can look at the table as well. I can of course define flexion lines, modify hooks, tangential stress reinforcement as well. Now let's have a look at, again I said define reinforcement, modify distribution widths as well. So here you can see all the different specifications and editing options that we can do for our reinforcements. Now of course we can have a look at predefined reinforcement as well. So we can predefine our top and bottom reinforcement here as well. So by selecting the element and also the specifications. So the type of reinforcement with diameter every so and so centimeters, and also the hooks that may need to be required every X centimeters here as well. Moving on, we have our punching shear values. So here you can see I get an option to look at the punching shear. Over here, I can amend the views. Same thing as the reinforcement, of course. I can look at the checks that have been done. So by selecting checks, coming over to the support that I want to check, I can select it. And here you can see I get a complete report on why on the failure report that I'm trying to have a look at. You can see here, this is the report. This is the check that passed, and then my failure check as well. So here you can see not only do I get a fail, but I also get a complete cutout of the code to look at exactly what I need to do to, for instance, amend this particular section if we weren't sure. Now, I can of course select only the ones that have failed in no time. So just quickly, what I wanted to mention was these reports can all be shared, exported, and printed as is here. So I can export to PDF, doc, all my different formats. I can share within the within my environment and share it with my project collaborators, stakeholders, etc. Or I can print it. I can also view the complete listing here in a full report that I can have a look at. So here you can see by particular sections, I have a full report looking at the punching shear checks that were made. Okay, so moving on, all the different editing options as well. So I can edit my punching shear. I can eliminate certain panels within the specification. I can generate reinforcement as well. I can add reinforcement on my own terms, and some things about the editing of perimeters as well. Now, that was the punching shear. Of course, I can have a look at panel data as well. So I can come over here and look at all the different subsections of my panel, and of course, define the base reinforcement as well for those here as well. We are able to design a slab of concentrated forces. That would be for load. I would have to come back here into beam definitions to load and introduce some loads here as well. Now, we went through this in a previous webinar, but of course, this is a sort of way that you would have to. You would introduce a point, line, or surface load onto the slab, and then the automatic generation of the slab, and your checks will be that will be taken into consideration. So let's move on. Let's move on here. Flat wall slabs, and that was basically it for the editing options for our waffle slabs. Now, of course, you can see these checks that haven't been specified. I'd have to go back, have a look at each particular beam. For instance, I can come over here to edit beam, and of course look at the errors that were done. You can see bottom compression reinforcement and anchorage due to compression. So I would need to again either increase my section or look at some reinforcement options that I'm able to do. But then again, this is we're running out of time, so I'm not going to look at exactly why things are happening. Just an overview. I hope you guys can understand that. So moving on, we have our contour maps. So here you can see the slab in its entirety, and also looking at the behavior of the slab as well. Yes, okay. So let's have a look. Forces, moving in the X direction, let's have a look. So I have my load case and also my combinations as well that I'm able to look at. So here you can see all the different combinations that I've defined. So ULS concrete, characteristic concrete, frequent concrete, quasi-permanent, and also my displacements that I can view. So let's come over here, and then you can see all my load cases. So let's have a look at the worst case that I'm able to look at. So this is a a sort of nice way to visualize the forces. What I can do as well is come over here to view the contour lines of the forces. I can as well automatically adjust the scale upon zooming. So you can see once I zoom, the scale changes. And also I can have a look at some values for my contour line. So here you can see the sort of concentrations where they're spaced out, and also the bottom bar here to have a look at the scale, the sort of measurements and values that are attributed to certain colors. Other options. So here, coming over here to average values in a stripe, I can select my starting point and select my last point and have a look at the moment, the distribution of moments along a particular stripe that I've selected here. Now, of course, that's just done here by clicking the average value in the stripe. I can, of course, have different options here as well. So things such as the midway value between 2 points, I can select this point. And here I can, of course, look at the minimum and maximum values and the average value as well. So here you can see I can define all the different, I can view all the different types of sections that I'm able to have a look at here quite nicely. So that's fine, beautiful. So again, I can view I can change my view for those reinforcements. I can have a look at the beams. So of course, I can have a look at the distribution of beam values. So again, this is getting quite muddled, but here what I'm trying to demonstrate is this sort of functionality that's present here. Now, let's move on. Let's go to the deformed shape. This is what I wanted to show as well. We can have a look at the shape of the deformed shape of my slab. So coming over here, I can of course select the maximum value. I can view the structure if I want to. So here you can see the structure that is defined. I can create a simple load case with my self load, and also let's make this 1. And view the waffle slab. So here you can see the concentration of forces and displacement. Sorry, that I can view alongside my my 3D view quite nicely. I can also look at the generation of a animation as well. So through time, of course, I haven't actually amended the scale factor. Let's make this 100. 200. And here I can actually view it a bit better. So the analysis can actually be amended. It can be customized to a great degree, and we can have a look at exactly why certain things are happening within my structure, etc., etc. And that's all with our 3D view. So the 3D view is quite a powerful tool. We can actually edit. We edit in 2D, but then with the 3D, we can consult our changes. We can consult our different options, our different views, of course, the behavior of the slab, of the beams, etc., etc. And it's done quite nicely. Now let's have a look. What else did I want to have a look at? That was basically, of course, the drawings. So just to wrap things up here, we can of course generate our reports. So here are all the different reports that we can generate with this structure. So job data report, I can have a look at that. Someone asked something about the bills of quantity or material takeoff, that can be generated here. I can basically generate a full job report on this particular structure. I can have a look at what we wanted to do was have a look at the slab reinforcement report. Now, of course, I can have a look at the first floor, and I get a slab reinforcement report that I can download again. So you can see all the alignments and all the values that I can download again, share, export, etc. There was the, where was it? The last one was the takeoffs. So I can, of course, generate my job takeoffs here as well. So all the different formwork and all my values, subtotals, etc. You'll notice that there is a watermark here on the side. That's fine. I'm just using a different version. If you guys have the program, that'll be abolished, the watermark, I think it's called. And also some, of course, so you can see all the different types of reports that can be generated. So reinforcement quantities per diameter, forces within columns, shear walls and walls, column displacements, distortions, etc. Can all be generated here. Now coming over to drawing selections, let's create some drawings. So all the different types of drawings I can generate here. I think that'll be enough. And also I can select the peripherals as well. So the different options for that, some text boxes, and I'll be able to edit these drawings once I'm inside the drawing generator. So just give it some time to generate these drawings. We didn't have any special loads for the time. So detail of the drawings, and here you can see my slab, my reinforcement drawings, my columns, as well as my foundation elements here as well. Now, of course, if I wanted to, I can of course generate these drawings and edit them how I like to. So here I can edit certain objects within the drawing. I can look at moving them, amending their specifications, etc., etc. So really, the sort of the freedom that we're afforded within CYPECAD is quite vast. Now that's it for now, and I think we're going to leave it at that. If you guys have any questions, these last 10 minutes we're going to have a look at answering some of these questions. But if you guys don't have any questions or anything like that, thank you so much for attending the webinar. There will be other webinars in the future. Just have a look at our calendar on CYPE, on the CYPE website, and you'll be able to view the changes. Now, there is some questions. Let's have a look. There was some from before. So I did show the punching shear reinforcements before. How to introduce wall partitions on the slab so that the related self-weight loads are taken into the analysis. That's fine. John asked whether you can insert wall partitions onto the slab so that the related self-loads are taken into consideration. They will be taken into consideration. So when you come over here to beam definition, you can create a beam, for instance, or a wall if you wanted to here. Come over here to wall, define the wall, and here you can see the types of wall that we can define, John. So reinforced concrete walls, plain stress walls for our, I think you mentioned partitions, yep. Reinforced concrete blocks and masonry walls. So upon introducing these walls, of course, those loads will be attributed to the certain location that you specify them, and you'll be able to see those loads once I insert the particular So that will remove the thing. So once I do generate those partition walls, those specifications and those loads will be attributed to the slab. I hope that answers your questions. And of course, they will be taking into the design with the analysis as well. Let's have a look. There are some questions. Let's have a look. What about the bill of quantities? So the bill of quantities was with that report generation that I can do. Let's have a look. If we don't have anything, we can have a look at some. We can have a look at an example project while we get some of these questions. Yes, June Solomon asked, does the program generate the design calculations? It does, and those are the calculations that I mentioned before. So we can have a look at defining, with each definition, we have the option to look at why particular things failed, why particular things passed, and with those reports, we can generate them as well. Now, I'm having some problems viewing the BIM Service Center. I don't know if that's maybe my internet. I know a few people have complained about the audio quality, so maybe it is my internet. I've got no idea. So I want to show an example project. Khaled asks, in the reinforced concrete wall, why the maximum thickness is 1 meter. I don't think the maximum thickness is 1 meter, but let's have a look. I can get back to you at the end. I can get someone to get back to you at the end, Khaled, about about that particular question, sort of a sort of specific one. Let's have a look. Some other questions. Let's go for one more. Okay, so let's accept this project. So this is a really extraordinary project that I've been invited to by my colleague. Let's just hope it loads. Bear with us one moment. So here we can actually view the building and also the load distribution as well. Deform shaped animations. Come on. Okay, so I think I'm just having some problems with the BIM Service Center, but that's fine. Let's go for one more question, and we'll wrap it up after this. Kuhn asked whether we can rationalize the waffle slab rebars. I don't exactly know what you mean by rationalize the waffle slab rebars. If you want to elaborate further, if not, I will get someone to make connection with you after the webinar to explain that particular to explain that query of yours. So let's just give this project one last go at opening, because I think I'm still having issues, but that's fine. All right, guys, it doesn't look like it's going to be working, but that's fine. I hope you guys got something out of the presentation. Thank you so much. If you guys have some problems, please don't be afraid to contact CYPE support. No matter what questions you guys have, if you guys have technical questions, please be very, because I know there are some of you in the webinar now that are using the program, of course. Please be very precise with your questions again, and also include screenshots, etc., and send those over to our customer service, our customer support team. Now, there will be a few of you that want this webinar, a copy of this webinar. I'll make it available to you guys if you guys have asked for it. That'll be fine, no worries. All right, guys, thank you so much. Thank you as well for attending. There will be other webinars in the coming weeks as well, so make sure to check those out. And thank you guys so much. Appreciate it. Have a great day. Bye.